Hi everyone, welcome back. Yeah, I think this should be live now. Should be going, cool. So this week, hoping to update the graphics for the enemies and add some animation, like some walking animation, and we'll see how far we get. Hopefully we'll be able to get into actually doing some of the hits. The hit code, so that it detects when an enemy has been hit, and yeah, we'll see how far we get. Let's see where we got to last time. Trunk serve, and can now go to 8,000. Nope, 80. Wrong. Okay, cool. So we've got this wonderful menu. This is, again, something, as I say every week, something we will make better at some point. But for now, we have our game. We've got our two little guys, and they currently just walk the back wall with some perspective. And last week we got caught up on, or I got caught up on, trying to make the perspective work. And this week I'd like to make them actually animate as they're moving, and to maybe have a different graphic as they're walking away as well, so we can tell which direction they're walking, and maybe start to randomize so that they walk about a bit and kind of within the room as well. So yeah, hopefully that'll be what we do. So the first thing we're going to do is go and update our images. So let's scroll down. Here we go, open. Cool, so we've got our little guy here. Actually going to make 4 copies. So these are the frames. The first and the third frame will end up being the same because they're kind of neutral. And then frames 2 and 4 will show the feet in different positions as they're moving. Hopefully that will give us the things. First thing to do, I'm going to save all 4 frames. This is going to take a while because there's quite a few pixels on this guy. Just wait for this to finish saving. Oof, that really is taking a while. Just gotta make sure that hasn't errored. Yeah, no, it's grinding through. There we go. Okay, well that's kind of indicative of how long it's going to take to save. There are some optimizations needed in the Pixel app. Should be linked in the notes. I'm just running it from there, from like a Raspberry Pi that I have on my network. Obviously the Pi is struggling a little. So yeah, that's unfortunately how long it's going to take. I've realized it's connecting over Wi-Fi as well, which might be making it slower. But yeah, as I say, optimizations incoming. I've got some plans for that, but we'll have to just wait and see how that works out. Okay, for now though, let's go in and first thing I want to do is, actually I'm going to turn the shader layer on. Ooh, that's interesting. Okay, it doesn't clone the shader layer. That's going to be an issue because I can't remember what the shaders were. I think it was 50% all around and then 80% on the soles of the feet. I'm gonna have to do each of those individually. That's gonna be annoying. Okay, so first thing, erase the front part of the feet, and I'm gonna have the right foot come forward. So I will sample the shoe, and go to the paint tool. I'm currently painting on the shader layer, that's no good. Yes, because I messed up the codes here, that needs to be 0. Okay, right, now, okay, now we've got this, so let's paint onto the background, there we go. Okay, so, kind of happy with that, gonna make it go up a little bit as well. Sample and round it off a little bit. Oop, sample. What's going on here? Sample tool. Oh, I can't sample the purple. That's interesting. Oh, I can't sample the purple. It's not sampling any of the colors. Okay, I'm gonna refresh the page. Ooh, that's interesting. It's chopped off the arm a bit as well. Okay, looks like I need to make some modifications on this as well, but that's okay. We'll go with that. Okay, it's now sampling. Don't know why that wasn't doing that before. So sample the brown. Oh yeah, first erase. Right, so what do we have last time? Let's go here. This guy. Do that. And then I want this one, so the left foot needs to then appear as if it's going away a little bit. Give them nice wide feet. Yeah, I like that. Okay, and then this one needs to appear like it's moving away. So we want less of this shoe here. It still needs to be as wide. Actually, I don't hate the amount that's there. I'll maybe put a little bit of shoe back in. And then I need to redraw the rest of this arm, which for some reason didn't. Okay, that's interesting. So I think what's happened is it thinks this line here is out of bounds, and I'm not really sure why. But we may just have to live with that. Actually, I guess one thing we can do is just even up the arm here, so at least they have the same on each one. I'll do that for every frame. Take that line off there. Okay, and go for another save, just because there was a risk losing it. Long save. Cool. I'm also just going to check and make sure the stream is live, because I've had issues with that, as anyone who's following the followed the stream will be able to attest. Yeah, okay, cool. I'm just checking on my phone. I am live. There we go, and it's finished saving, so that's great. Cool. So yeah, really, we just need to do the other to do this frame as well. So what do? We skimmed off the shoes. And make it look kind of even. Oops. Nope, still had sample selected. Sample. sorry, what I'm trying to do is match the left foot so that I can copy it on here. Okay, it actually goes out one whole thing more. There we go. Cool. Okay, so that's now matching. So now I can copy this shape onto the other ones. So it goes 2 and then 4 and down, and is that it? That actually might be it. Yeah, it sticks out to. Great, cool. Okay, and now we'll copy this other one. Basically, just expands into there. So 1, there is 1, 2, 3, 4. So there's 4 across the top. 2, 3, 4. Yep. Then down 2, and 1, then 2, and then 1. I think that's. Yeah, that works. Is it 2 on there? Yeah, it is. Cool. So you can kind of see a little, as I switch between them, you see a little walking animation. And we'll have a look. See what that looks like. Yeah, okay, it kind of works. I think I might have to yeah, I think I'm gonna have to change the neutral stance so they don't stick out quite so much, because that looks a little bit daft. Got an interesting gait to them, right? So what we'll do is we'll actually have different images, I think. So this original image that looks like this one, which is a single frame, we'll make that the weighting stance, and then we'll actually have a whole separate pixel sprite sheet for when he's moving. The soul, yeah, okay, I like that. And then this one will do the same thing. Okay, that matches apart from frame 3, missing one there. Great, cool. Okay, so now we can see from the animation, yeah, it looks kind of like he's shuffling. Unfortunately, he's too big, so the zooms don't work. Yeah, again, something else I need to work on to make sure that they actually fit. But from the tiny little animation here, we can see that it's kind of working, and it looks like he's shuffling. I think I'm also going to do in the shading. I'm going to make sure that. Oh man, it's really messed up the shading, because actually maybe that actually might be quite cool. Because it looks like it's put a shading in there. I'm going to put a little background on. You can see the shading on the shoe is sort of stretched out, and I don't know why that's doing that. What happens if I erase? Yeah, okay. I need to work on this to figure out why those things are going wrong. But for now, we can just copy the shading onto each of these. So I seem to remember the shader was 0.5 in there, and that was on each of the things. Yeah, it was. So it's just essentially going around the outside to highlight, and And actually, now that I've cut the arms off, I need to add that back in there. Yeah. Cool, I think yeah, the shading went all the way down here. And up here too. What we'll do is a similar one there. Oh, I've accidentally put one in his armpit. I can't undo it. Should just zoom in, that'll make this easier. So what happens if I apply 0? Yeah, okay, it does undo it. Right. Apply the shading a little more heavily on this side. Just to indicate that it's going backwards. Oh, I think, yeah, I messed that up. Just checking if the medallion is shaded in, which it's not. So yeah, this whole brim of the hat is shaded. I think everything down here was shaded. And I just need to do the cowl part. Turn the animation off. Okay, that looks pretty good. Oh, the armpit's still in this, actually. Let's try and remove that. Yeah, cool. Okay. Let's have another go at removing these. Okay, this is working now. I don't know why it wasn't working before. Cool, okay, that's tidied up the first frame. Cool. Right, so the right foot is going forward, so I'm going to put a bit more shading on this arm. And it's not working for some reason because I've set it to this again. So it's just to sort of make it appear. Oh, I've just realized there's some extra shading on the left there that we need to get rid of. Okay. change the background color a little bit. Let's add a little bit of red in there. There we go. Just to give us some contrast. Yeah, I can see there's more little bits of shader that need to be removed. There we go. Not sure how obvious this is on the stream. I know it's a bit crushed the graphics a little bit. Hopefully it's clear. Right, and then we're going to add some shading just to round off the shoe. Cool, and that's the neutral one done. Actually, I quite like the idea of adding some shading in along the bottom here as well, the bottom of the cassock that he's wearing. So that's the neutral pose. In here, I want to give the impression that this is moving backwards a little bit, so I'm going to put some shading around the cassock. And then I also need to put a 0.8 shader on the sole of the shoe, because that's how we're making that look darker. Cool. Oh, I noticed a shader up here as well, 0.0. Just one little one leaking there. Oh, there's another one here. They're not super serious. This probably won't be that noticeable, but it would be good to get rid of as many as possible. Yeah, you know what? I'm actually going to do a 0.3 as well, and just do a little bit of extra shading on here. Subtly add the disappearance. In fact, I might do the same thing on the arm. To try and give a sort of progressive look to it. Yeah, I don't want to get too bogged down in mastering the graphics, because I think that we can work on that. And it's not particularly exciting to watch someone colouring in a frame. But I'm going to save that again. It'd be cool to get the multi-frame going for that, because we did the Fireball. There's a multi-frame thing where we switch between different frames on the pixel sheet. So it'd be good to get that with an enemy and tie that into the movement as well. Cool, that's finished saving. So let's pick up this guy. The shader we want to set to 0.5. Sort of remembering how this hat went. And this is the neutral position, so I'm not doing any shading, any sort of complicated shading on the arm. This just needs to match the first one. I slipped that. Added extra in. I'll just get rid of those. 0.5. Now we just go around the shoe. Cool, I think we're almost there. We're at 0.8 onto the sole of the shoe. Yeah, that matches. I can't see anything changing in between those. Great, so penultimate save, and then we'll finish off the last walking frame on there. So yeah, one of my plans for optimizing this is to, instead of, because at the moment in this application, it takes every pixel and treats it as an object, and puts it into a huge long list, and then sends this massive list to the server, and it can be, 2 or 3 megabytes of data, and then it's looping through and adding each pixel or each square individually, or updating it if it already exists. So it's like having to check whether it exists. If it does, then it overwrites it. And really what I want to do, I think, is in the front end of this, to track just the changes to optimize it. But that's not really what the stream's about, but it will make it faster for the future. So I will work on that. I'll try and put it in during the week. If anyone wants to submit a PR for the application, please feel free to do so. I've got lots of planned things doing. It's very, very early stage at the moment. In that it's almost pre-alpha. I'm hoping to add like a line tool and a circle tool but they're just in the backlog at the moment, as unfortunately life gets in the way of doing these things. So 0.5, there we go. Go down here. Good news is this is the last one, and once we're done here, we can start to actually write some exciting movement code for the enemy wizard. That's it. Okay, other than the shoes, yeah, we're going to do the shoes. I'll do the soles of the shoes next, and then compare to the second frame. Just to remind me what we did. Oops. Second frame, yes, we added shading to the arms, so I also need to add a 0.5. I think it was that, yeah, it was the bottom ones, and then it was a 0.3 on the other bit. 3 in here, and how far up did it go? Oh, the next 4. I've sort of messed this up somehow. I don't really understand, because it's now sticking out the top. That's why. There we go. So that's looking the same, and then I need to add a 0.3 onto this bit here to give that fade effect. I think it does differ ever so slightly. Oh, hang on, I've missed some. Shading on there. Okay, no, I think that works. You know, I'm actually thinking, I think maybe sticking a 0.3 shader around on the neutral stance, give it a little bit of a depth boost to that, just to the overall view. Cool, so final save. I think we've got everything. Yeah. Yep, pretty happy with that. Okay, saving that. And then we'll move on to the render, and we'll go back to the actual code. Just gonna check on ABS. Yeah, cool. Okay, the audio is still going. Sorry, I'm like super paranoid now after the second one, where I had an issue where it didn't actually stream. Super paranoid, it's not streaming now. So we go back and saved images and scroll all the way down to the bottom. Want to render. Okay, we can see our little guy here. We can also do get GIF. This should. Oh wow. Okay, that has not worked. I mean, it's working. You can kind of see the feet pumping away. It's obviously very fast. The GIF is just an indicator. But let's do get image sheet. I think the reason it didn't work was because it tried to add a black background, but whenever there was a shader, it added a white border. So I think hopefully we should be good. We can see we've got each of the things here. So we'll save the image. And go to VCC clan, assets, images, and what's it? Walk. Okay, cool. Right, so now we're going to need to go to the enemy wizard character, and we're going to need to add in a new constant. Call this walk. Just add walk on there. Add the walk image finally into the actual struct. So we now should have that within the thing, but it's telling us that it's not moving. So we need to add some movement code, and the way I'm going to do that is just constantly create new destination locations. Point new XY. So it's actually going to start at its destination location, and we're going to, in the update loop, check. So if dest self.destlock.x not equal to self.lock.x, or self.lock.y not equal to self self.desklock.y. Let's just move these around because it's a bit weird to have differently formatted logic. There we go, that's better. Now the two sides of the OR mirror each other. So we'll leave a message. So create new destination location. Now I don't. We're going to have to add in a random number generator as well, and I don't think we've done that yet. I'll check in cargo. We've got. Oh, we do have rand installed. So let's have a look. Oh, we used it on the Fireball. Where did we use this? Oh yeah, we used it to randomly select whether the whether it would show the bit coming off. So those little fireballs pumping off left and right are randomly randomly picked. So yeah, okay, that's cool. That's cool. Right. In which case we can just copy the random number generator. So let's new x equal. Actually, no, we need to create a new object first. Let's copy the entire random number generator. And range gen range. There we go. And this will give us a new destination, and it needs to be between 0 and 100. Can I cast the result directly into F64? Yes, I can. Okay, it doesn't like that. No method for struct gen range. Oh, is that because I haven't imported ran. Wait, what? How is this? It's called ran. So where is RNG used? The random number generator objects. Actually, not using that. Okay, it must be pulling in a trait or something. Method. Yeah, okay, yeah, it's pulling in a trait, that's what it's doing. Rand RNG, go, and hopefully the squiggly line disappears. Yes, it does, great. And new y equals range dot gen range, oops, 0 to 100. Actually, I'm not going to have him come all the way forward. Excuse me, I think maximum 80. Otherwise, it's going to come right up to, so this one starts at 100, so I don't really want them to come up all the way to the front. I want them to just come 80% of the way, so it should be coming to about here. And they'll just kind of shuffle around the room. Yep, and then we need to set self.desklock.x equals new x, and self.desklock.y equals new y, and we should get a squiggly there because it needs to be an F64. Oops, so we cast that. Cool, so it sets it as a castable thing. And then I also wanted to have a weight as well, because we want to display the regular image and have them just wait in a location. So I'm going to say, call this wait time, and that's an F64. And the wait time is the initial one, let's make it a second. So it should pause for a second before starting to move backwards. And we'll come to the update. And that works. So got if self dot we call it wait time is greater than 0, then self dot wait time minus equals delta, and then return. And then as soon as it gets down below 0, then we'll start moving again. And we should be able to see this in action. Because it now should mean that they pause for a second at the front before moving back, which they do, which is cool. So we also, upon them getting to their location, we want to set self.waittime equal to rndg gen range and I'm actually going to create some new constants. Const enemy wizards min weight 64. I'll set that to be 1,000, and then I will also create the corresponding max weight, and I'll set that to be 4,000. Cool, so we'll get a random wait time. Then we can, I'm gonna cheat for now and do, oh actually no, let's do it properly. Self.lock.x. I was going to essentially subtract the enemy speed from the x and y coordinates separately. The problem is, what that can give you is that it'll kind of move at 45 degrees until it lines up with either the x or y coordinate and then just move sideways, which looks a bit rubbish. So I'm actually going to use some geometry to make sure that we get the angle location. Now, did I create... I didn't create the function yet to get the angle between 2 points. So, okay, because I didn't do that, I'm gonna do this for now. If self.desklock.x is greater than the current location .x, then self.lock.x is plus equals delta times enemy wizard speed, and then if self.lock.x is now greater than self.desklock.x, it means that we've passed where we needed to go. So we'll actually just set them to be the same. Self.desklock.x, and that will trigger the first part of this. So it means that we'll then go and get a new location to get to, and then we need to do else if self.desklock.x is less than self.lock.x, then self.lock.x minus equals delta times enemy wizard speeds. This is a clumsy way of doing this for the reasons I've described, but we'll tidy it up in a minute. Is less than, then it's going to be, yeah, okay, cool, and we'll just copy and paste and do the same thing for y. Just change all of these to y. Okay, so pause that and let's see what our little guys do. It's got the second pause and it should be picking out locations. Okay, it doesn't like that, so I'm going to inspect the console. Nothing on here, so we've made an error, or I've made an error for some reason. Because it should... Oh my gosh, I've made a fundamentally incredibly stupid error. I've done a, in the logic at the top, I did not equal to, which of course if it picks random locations, it won't ever be, so it's just picking random locations and never moving to them. So that's what happens while you're talking instead of thinking about writing code. Okay, they're still not moving. Okay, no, they're moving now. Yep. Okay, that's really cool. Yep, so they're now moving about and waiting when they get to their new locations. So there we saw an example of he moved 45 degrees until he lined up with the location he was at and then moved backwards, which is something we're going to improve in a minute. We've got a problem that the one on the right, because he was added second, is rendered second inside the vector. And that's because it's just looping through and drawing them in order. And actually we need to draw them in terms of render distance. So whoever's further back gets drawn further back instead of just overdrawing, because that breaks the immersion. But there they are, they're scooting around the room in random locations. So I think now we should actually add the geometry in to make them move towards their given location. And to do that, we're going to need to steal a function from a different project that I have, which I know this is ever so slightly cheating in terms of I said that I would write all the codes. I think I've copied code before, so it's not entirely sticking with it. But I have this other project I'm working on yeah, here we go. It took me ages to figure this out, and so I'm not going to do it on stream because it would just be embarrassing for me. So this is inside utils, and it's essentially gets the rotation between 2 points. This might be easier to illustrate with Microsoft Paint, actually. Let's have a look. So I can draw, right. So okay, got it. Yeah, so I use my pencil. So essentially we've got our rotation. So this are X and Y coordinates, and all rotations exist on this circle. So essentially a rotation of 45 degrees would be here. So yeah, we also have, I tend to work in radians with this because otherwise you have to do conversions between degrees and radians all the time. So 45 degrees is actually pi over 4. 90 degrees is pi over 2. 180 degrees is pi. And 360 is 2 pi. This is 3 pi over 2 there, and so on and so forth. So we'll be working in radians from now on. But what we want to do is want to get, so say we've got 0.1 and 0.2, and we need to get the angle between them. And obviously looking at here, we need an angle of this amount here. So it's this angle here that we want to know how to move. And the problem is if we get a point down here, so the point between the rotation between 0.1 and 0.3 then needs to be all of the way around here. So we've got a much bigger number, which would be pi plus pi over 4, for example, assuming this is 45 degrees. So this would be 45 degrees or pi over 4, and then this would also be this little section here would be the same as this section here, meaning that we've got to have pi plus pi over 4 here. And the reason we want this is because we can use this, this is called a unity circle, and you can actually describe this in terms of sine and cos. So the x coordinate is the rotation multiplied by sine. So it starts at 0 and then tracks up to 1, maximum of 1, and then goes back to 0 when you're halfway through, and goes to -1 when you're 3/4 of the way through, and then finally back to 0 again. And if you track that against how a sine curve looks, it looks like this, starting at 0, and at 360 degrees or 2 pi, it's back to 0. So that's how a unity circle works in the x coordinate, and in the y coordinate it's the same thing, but it works with cos instead, which starts at 1, because at y you want this to be 1, and then at 90 degrees goes down to 0, which of course is here, so the y coordinate is 0 here. It goes down to -1 at 180 degrees, and back up to, it kind of trends to 1 again there. So, sorry, I missed a bit off. There we go, and that's back at 2 pi, it goes back to 1. And by tying those two things together and using that function to generate this, we get this circle. And that doesn't seem entirely useful until you realize that actually if you treat this as your player character, it means that you can use sine and cos to figure out how far they should move based on movement. And I'm hoping to do like a proper formal video with like actual slides and stuff at some point, explaining all of this, because it kind of took me a while to get my head around, but it's super useful for character movement. So many early games, simply if you were holding the left or right arrow, would add or subtract the movement speed, and same for the up and down arrows, meaning that if you were holding both an up arrow and a side arrow, say up and right, you'd actually end up here, which is a bigger distance than here or here, meaning that you've actually moved faster in the diagonal. And one of the speedrunning hacks they used to use on some older games was to run diagonally up maps and things, because it was much faster. Using this, you can be sure that you have a uniform speed, because for every game cycle, you just move like this distance or this amount multiplied by the speed that you're moving. So you can scale this circle up and down based on how many seconds have passed since the previous tick. That is a really terrible explanation of how this sort of thing works. But the first thing that you need is you need to be able to get the angle between the points. And we do that by finding the difference in x coordinate, the difference in y coordinate, and calling this arctan squared or arctan 2 function, excuse me, between the difference. And we actually, in order to normalize, because I want to get the angle of rotation around starting from 0 here. So yeah, 2 pi is also the same as 0 on the unity circle, or on this function. And so we do 2 pi minus. I can't remember exactly how I arrived at this summation, but this, for any 2 points, will give you the output that you want, the rotation that you need to be able to use within the function. At least I think it will. I may have over-optimized. Oh yeah, I also need to copy this normalize angle function. And the reason for this is this simply takes an angle. Well, I'll show you the code, and then we can see. So the angle here, if it's less than 0, it adds 2 pi, which is a constant I defined at the top. Oops, put it here. There we go. Oh, it's missing. It's missing the A10. Yeah, okay. So we've hit upon. Oh no, that is okay. So I was just thinking this is a problem because it's actually imported from JS because it's a WASM project, but this also is a WASM project, so that's fine. Cool, okay, so it's just warning us that these functions are never called, which is fine. But yeah, essentially if the angle ends up at less than 0, then we just add 2 pi to rotate it back around. If it's greater than 2 pi, then you subtract 2 pi to move back around, otherwise you return the angle itself. And the reason for this is so that when you call the get angle between points, you always get a value between 0 and 2 pi, or could be equal to 2 pi. Yeah, that just means that when you're debugging, you can look at the actual angle and not some calculated value that's like 2 or 3 times the angle, which would still work mathematically, but it makes debugging a lot harder. So we get the okay, so if we've actually, we want to return here because we're always going to have a wait time. We want to make sure that we skip back into this part. So otherwise we're going to like jerk a little bit in the right direction and then stop and then wait for our wait time and then move. So we don't really want that. Right, so let angle to destination. It's going to be equal to get angle between points, self dot oh, that's a good point. Is it start x? Yep. So start x is the self.lock.x, self.lock.y, self.desklock.x, self.desklock.y. There's very much an optimization here, which is that we could change the function signature to use points. In fact, let's do that because we have, so we'll just call this start, and that will be a point, because it's actually in the same file where it's declared, so it shouldn't be too much messing about. Points, and this just becomes end x minus start x. Cool. And the comma. Okay, and it doesn't like this. Will it give us the... Yes, it gives us a quick fix, which pulls in the utils get angle between points. We're already pulling in point anyway, so that's good. Okay. Oh, doesn't, because it's behind a mutable reference. Okay, yep, that needs to be. Okay, why doesn't it like that? Yeah, expected point found. Yeah, because these aren't simple types, we need to pass them in as references. Yep, and then we just pass that as well. Cool, okay, and then we set self.lock.x is going to be equal to angle to destination sine, the sine of that, multiplied by the delta times enemy, was it speed? And self.lock.y is equal to angle to dest.cos times delta times enemy wizard speed. So that, oh, hang on. This needs to be plus equals. And one thing I can't remember is if it needs to be plus or minus for the cos component. So I'm going to just comment that out so it's not working. And the reason for that is the inverted axis on a... oh, hey, sorry, I've got a comment there. I'm really sorry I didn't see that until now, and it looks like you're no longer watching. But yeah, hi, waving asan.dev. Anyway, where was I? Yeah, so the inverted y-axis on this could cause a problem. So it could be that this is wrong, but the way that we'll check this is actually to set a new point, and I will set it to 50-50, which is halfway down. So we should see the two guys converge on the middle after they've hit their waiting periods. Let's see if that is in fact the case. Yep, as expected, they're moving in the wrong direction and they're moving too far forward. There we go, minus. And they're heading to 50-50, and now they should pick a random location. And after the pause, oh dear, that looks horrible. The two drawing on top of each other. Okay, so something's gone wrong. It's it's not picking a new location, a new random location. And I suspect the same thing will happen if we revert this back to passing in x and y. Should refresh itself. There we go. Yeah, they're like buzzing backwards and forwards. Okay, I'm not sure what's going on there. Actually, I think I know exactly what's going on there. They're getting close, and they're not quite, they're never quite able to hit the exact spot. So what we'll do, put in a little fiddle of if self.lock.x minus self.desklock.x abs. So we're taking the absolute value, so basically throwing away any negative signs if one is bigger than the other, is less than enemy wizards, what should we call this? Close destination accept, let's call that. So this is the amount that we will accept being away from our location. And set that to a 0.1. I think that's, yeah. So it's kind of like if it's close enough. And if we get this problem again, I don't know if it's possible to see on the stream, but it's like they're shaking very, very fast, and it's because they're hopping over the point they're trying to get to, but never quite getting in there. And I'm hoping it's going to be quite a small variance on that. So where were we? Okay, well, I'm just going to search for this because I know that I created, there we go. Oh yeah, actually, and then I need to do an and, because also need to make sure that the y is close enough. Self.lock.x equals self.desklock.x, and self.lock.y equals self.desklock.y, and that should then trigger this code at the top again where they are exactly equal. And that's one of the downsides with working with oh, hi Akif, Abdulayev, nice to see you. Thanks for stopping by. So anyway, what was it? Yeah, so we've now got this kind of, it's like a fiddle factor, and it's like how far away we'll accept before we get this, and we'll set these to be the same, and when they're the same, it will work this. And because we're working with F64, which is a floating point number, that's where this problem has come from. So we rerun this, and oh, thank you very much, that's very kind. Yeah, so we wait our 1 second delay, which we put in, and then they head to their destinations. Cool, that is working. Yep, they are moving around, and they're moving kind of directly towards the positions. We've still got that problem with the overdraw, where one of them is overdrawing because they're further back in the asset vector, and that's kind of breaking the immersion. But in terms of the movement, I think that's now working. So yeah, cool. Unfortunately, time is marching on, and I don't have a huge amount this evening, but I will try to. I think the thing that's standing out to me is that overdraw effect. So I think we need to figure out how to order the vector, and I'm sure that Rust has a sort vector, like has a way of sorting that. And there we go. Sort a vector. Sort a vector of struct. Here we go. This is what we want. Sort by. There we go. That's what we want. Okay. So now for every redraw, we will sort through and sort them into the order they need to draw. So that happens in game, I think. Yes, it does. So this is the render, and we do the updates here. I think this makes sense to happen here. So I've copied this, but we're going to do enemy.sort, sort by a b, and we're going to sort by they're the enemy type a dot location dot y. Oh no, hang on. b dot location dot y dot comp at a dot location dot y. Okay, why doesn't it like that? Cannot find, oh. Self.enemies, that's why. Okay, right, we've got field lock is private. Okay, let's, easy to fix that. We'll just make it public. Ooh. F64 is not an iterator. Why is it trying to compare iterators? Probably should have read this code a bit more thoroughly. Sort people by age. So what is that? F64 is not an iterator. Yeah, why does it need to be? Okay, time to Google the sort by and just see how it actually works. Okay, let's go to Stack Overflow. Interesting, this one has the opposite logic, so it's saying comp. I'm guessing that's because it wants to do them in reverse order, but yeah, I don't understand why it won't call this comp. Am I missing a trait? Ah, okay. I think it might be this, that we're missing the ordinal and partial ordinal, and the derive on the enemy wizard. Might as well stick the other things in as well. Probably should have done those before. Ord. Okay, and hey. Oh man, it does not like that. It's not satisfied. It's not implemented for point. Okay, then just what does game think? Oops. Okay, no, it still doesn't like that. I don't. F64. I don't understand why comp is trying to do an iterator. An example doesn't. Right. Okay. So I think all the partially Q and partial ORD, all that does is to allow the sort, but we don't want to sort. We only want this customized sort. So I shouldn't need that. Shouldn't need to derive all that stuff. And I'm guessing it would tell me, but I just don't understand why it's talking about iterators here. F64 is not an iterator. Well, no, it's not. The following trait bounds are not satisfied. Required by athlete. Okay. Maybe it's a trait and you have to pull it in. Doesn't think it's being used. Okay, yeah, I think it's a trait and it's pulled in these, yeah, in these traits. Okay, so we need that. but then I'll have to do it for point as well. So let's do strive. Okay. Is not satisfied. The following types are. Oh, okay, that's interesting. Ord is not satisfied. For F64, that's weird. Satisfied for F64. Okay, well this is where our problem has come from, is that we can't do comparisons on F64s apparently. Oh, okay, it's only, maybe we don't need ord. Let's see. Oh, okay. And EQ. Yeah, okay. So we'll just do partial quality and partial ordinance. Okay, let's see. Jump back to CMP. Okay, it still doesn't like it. Right. Okay. Well, we're zooming in on the problem. Rust vector sort by F64. How to sort a vector of floats. Yeah, okay, that's what I thought. The method requires the ord trait because of not a number. Oh, that's interesting. Okay, because it can be not a number. Oh, look at that. We can just copy this. So, okay, yeah, that looks good. We can just implement it by hand for point, I guess. I'm guessing I have to do equality as well then. Oh, right, yeah, we don't want to derive those. Just want to implement them, okay. Ah, why is it not? Okay, unexpected argument of type point. Yes. No, that's not right. What? How is it an unexpected? It's going to be that one, right? Oop. Use. Okay, so we use that. So we're doing ordering. Okay. Unexpected type point. Expected one argument, found two. So what does the signature partial comp look like? Oh, yeah, I imagine it's that. Yeah, okay. Self.partial. Okay, maybe that works. What is this? Okay, but it doesn't like, right. Yes, so we will. This is surprisingly difficult. I was not expecting this bit to take quite so long, and it's because it's you know what we could do is just be really clumsy. We could just convert it to an i32 because we don't care too much. What problems could that cause? There's a 50-50 chance it would overlay if they're within a certain amount of each other. We can reduce the amount. Yeah, okay, no, actually that works. Yeah, let's create our own hacky version just for now, and I'll try and read up on this problem during the week to figure out how to implement the comparison for F64s. So, and the big problem we've got, or that I can see, is that I actually don't want to do a straight up comparison. I only want to compare on a single key, and that's what's making it difficult. And it's all because we created this point rather than using a simple thing. So I'll leave those in there for now, but I think I can get rid of them. But we want to do let a val equal, I'm going to make sure it's an i32 because it is implemented for i32, is equal to a.lock.y as multiplied by 100. I'm going to add some more refinement, so it's going to be good to 2 decimal places. And we'll do the same for bval, b.y, and then we'll do bval.comp at aval, and return that. Ooh, okay, no squiggly lines now, so that's a good start. And then, as I said, I think it was in utils, yeah. So I'm going to comment that out and then comment those out. Hopefully we don't need to add these. I'll delete them if it works. Oh, wrong window. Oh, did I close it? I must have closed it. I'm not seeing it now. Go localhost 8000. Nope, keep going to 8000 for some reason. 8080. Go play game. Cool, our little guys are back. That is not working. Okay, I'm gonna set a. Yeah, the second guy's still drawing over the top of the first guy. Even there's some sorting going on. I think it's in the wrong order. So I actually want to, in game, I want to do aval comp bval. I want to just switch the logic. Wait for them to move. Hopefully they'll cross over soon. Okay, that's correct. Oh, he got stuck a little bit, but then unstuck himself. Oh, they're very far apart. I just need to make sure that this guy's not always okay, yeah. That's correct, yes. They're now drawing. Yep, guy 2. I just need guy 1 to go in front again, just to make sure that he's not. Really not sure why they're getting stuck at the end. Might be because they work in a very smaller thing. Come on, this is guy 2. I need him to go behind. There we go. Yeah. Okay. Awesome. It's working. It's doing the proper. It's drawing them in the right order of values. So that is brilliant. Cool. Well, yeah. Unfortunately, as I say, it's taken a bit longer, and the that render distance code took a bit longer to figure out than I was hoping. But I will tidy up the code, and then I think, unfortunately, this is going to be it for this evening. Or we could have a go with having lots of enemies, actually. Let's see what that looks like. So we should end up with 4 of them. That's cool. I really like that. Yeah, and they phase through each other at the moment. I think I'll need to figure out something a bit better in the future. But yeah, I'm pretty happy with that. So I think the next stage is going to be, and as I said, I don't have time today to do this, but maybe during the week or maybe next weekend, will be to have them actually fire fireballs at the hero. And then also to implement some hit codes to see when they are actually hit and set them on fire and have them crumble into dust. But yeah, I kind of happy with how that went. It's a shame that we didn't even get into the animation side of when they're moving. I wonder if we can hack that together really quickly. Yeah, let's see if we can. We'll just try and steal code from here. So we need the frame. Move frame. It's just an I32, I think. Isn't it curve frame? Yeah, I32. After wait time. What do I call it? Move frame. This is the delay between frame. Oops. It needs to be 0. There we go. Oh yeah, we're gonna have to have a time to frame as well. Yep. And that needs to be an F64. To frame F64, and that's just to make sure that we've got we wait the correct amount of time to move between. Don't need any of that. Time between frames. Enemy wizard walk. Enemy wizard walk frame. Frame delay. What frame delay did we use on the fireball? We time between frames 60. Okay. We'll start with 60, see what happens. It might be, that sounds quite fast for the length of animation that we've got, but we'll see how it works. Self.walk frame. Hang on. To move frame. Okay. So I want it. Wizards. Ooh, that needs to be the calculated output. No, it doesn't. No, sorry. Wizard frame width. Self.image.size. Oh, self.walk image.size. Image.width even. Yes, okay, this should, so that should work for cycling through the frames, and then in the render, we need to get the image. Oh, yeah, and we're gonna have to go through, okay. So let's have a look at here. So we've got to calculate the offsets. And we also need to calculate the image. self.log.x not equal to self.desc.log.x, or self.log.y is not equal to self.desc.log.y. Then we are moving, so we want to return a reference to self.walk image, else reference to self.image. This needs to be just image there. And okay, so the X, Y, output width, output height. And that is the offset. So we will create let mute offset equals 0, and then we only need to offset equals the self.move frame as 64 multiplied by self dot, oh no it's not, it's enemy wizard frame width, I think, and I'll just check that. The offsets self.coframe multiplied by image width, yes it is. Okay, okay, what doesn't it like about this? Expected integer, yeah, I'm sure you did. Offset. Okay, if we're very lucky, this will have worked and we'll be able to add our animation in. Let's have a look. It does, look at the little feet waggling. When they wait though, they do seem to be not reverting. Oh, he reverted to the original image and he didn't. Yeah, some of them, sometimes they're not, sometimes they're stopping on the offset. Okay, that's, oh, I know what we can do. Yes, instead of checking for that, we'll just to if self.wait time is greater than 0. Then no, it's less than or equal to 0. Yeah, then we will be moving. Yeah, I realized I got the logic wrong. That's yeah, I was doing the wrong thing. But yeah, now when they're standing, they're doing the full, you know, leg spreads. Okay, I'm gonna just slow down the animation, the time between animation frames just a little bit. Really, if I wanted this to be smoother, I'd add more frames in, and at some point I probably will, but I just want to try this one out. Yeah, there we go, that's a bit nicer. See them moving about. Yeah. Okay, well, we've got a room full of enemy wizards and they're moving around. And we've added in the animation, which was what we wanted to do today. Don't know why he was walking into a wall for so long there, or that they were carrying on walking. Not sure about that, but yeah, very strange. We'll try and figure that out. Why they're not getting in close enough. Ah, maybe it's the catchment. Yeah, okay, let's try setting that to 0.2 and just see if that smooths that out. Because I was noticing them buzzing a little bit as well before. Okay, yeah, that seems to have fixed it. That guy moved very fast up the wall there. Awesome. Well, I'm really happy with how this turned out. Thank you very much to everyone who's joined or anyone who's watching on the repeat section. Yeah, it's been really fun. I've been Phil. Please consider subscribing. And I will post the code to the GitHub repository linked immediately following this. Take care of yourselves and hope to see you again soon. Hoping to get another stream in next week. But yeah, until then, I wish you a good day. Bye for now.